Unless there is a strong feeling that I should pick
Yes.
this.
Let's check it first.
Oh yeah.
Alright, let's check first. Let's be safe. Alright.
I mean,
Alright, number one, this is where it just says, like, state the mean value here. Yeah, so like you looked at your notes and you just like wrote down. Good. Okay, mean value theorem. What has to be true?
Continuous.
The function has to be continuous, but be specific. Continuous where?
On
On a closed interval. Think like bear claws. Closed interval. And differentiable. Open interval. If you have those two things, here's the part that doesn't come out of the mouth really well, right? Continuous on a closed interval, differentiable on an open interval. What do you know for sure?
See,
that value.
There's a C inside the interval where something special happens. And that something special, oh, what? All right, David.
the tangent, the slope of the tangent line is the same as the slope of the secant line.
Perfect. If you have a continuous function on a closed interval, differentiable function on an open interval, then there is always some magic value of C inside that interval where the slope of the tangent line at that point is equal to the slope of the secant on the interval. Everybody okay? Now this is one of those existence theorems, meaning that there has to be such a place. You don't always know where it is other than it's inside the interval. Okay? Now could there be more than one?
Yes.
Right, with an existence theorem it says that you're saying you have at least one, but there could be more. Alright, number two, however, you should not be applying the MVT for the tangent function on the interval negative pi to pi because we know tangent has vertical asymptotes inside that interval, so you lose continuity. To b, f of x equals the cubed root of x has a problem. The graph of the cubed root of x, if I had really drawn it properly, what you'd see is you'd have a vertical tangent line over here at x equals 0. Vertical tangent lines are hard to see, but if you took the derivative of the cubed root of x, you get 1 over 3 cubed root of x squared. What's the problem with the derivative? How do you see there's a problem in the derivative? Lewis, how do you see it?
There can be 1 over 0.
Right, if x is equal to 0, the denominator is equal to 0, the derivative wouldn't exist. This is the problem. Everybody okay? Okay, good. Alright, number 3, now 1/4 x cubed plus 1 is continuous because it's a polynomial. When I take the derivative is a polynomial, so that exists, so the MVT applies. I'm going to find the slope of my tangent line, f of 2 minus f of 0 over 2 minus 0, and I get 1. And then I find my derivative, I set my derivative equal to 1, and I solve it, and I get plus or minus 2 over the square root of 3, or even better, 2 square roots of 3 over 3. Everybody okay? So, Andrew, how many solutions here?
1.
Just 1, even though I wrote 2 here?
Yeah.
Why is it only 1?
Because it's only from the interval of 0 to 2.
Right, we're only interested on the interval 0 to 2, so I'm only going to take the one value that is inside this interval. Alright, number 4, x minus 1 over x. Can I use the mean value theorem here?
No.
Yes.
yes, because f of x is continuous except at x equals 0.
Right, this function over here doesn't, the function doesn't exist at x equals 0. I'm going to have a vertical asymptote, but that's not inside the interval, so okay. I move on and I take the derivative. The derivative is 1 plus 1 over x squared. That derivative doesn't exist at 0, but again, not in the interval. It's a, yeah, so that's okay. I got a little bit worried there.
Is it okay?
It's okay. So then we do f of negative 1 minus f of negative 3 over negative 1 minus negative 3. We get 4/3. Set the derivative equal to 4/3. Solve it. C is going to be negative square root of 3. You have to pick the one inside the interval all the time. Giselle, you okay with all this? You're like, whatever. Where's my donut? Alright, and...
Okay.
Let's be real. Alright, and 4b, you've got a function. I'm pretty sure that function's continuous on this interval. I take the derivative doesn't exist. There are 2 places where the derivative doesn't exist. I'm wondering if anybody knows where.
What was the question?
The derivative
Not exist.
doesn't exist in two places. I'm wondering if anybody knows where.
5.
Look at that function, look at that function, look at that denominator.
Wait.
David's already half right. 5 and -5, because both would make the denominator equal to 0. Are either of those in the interval that I care about?
Yeah.
Not really.
Yeah.
I mean, but it's not like.
Negative
It's
five.
not
No,
in
because-
between -5.
Because in order for
In between.
differentiability,
-5, -4,
Yeah.
-3,
Uh,
-1,
In order for, differentiable stuff, the MVT says continuous on the closed interval and differentiable on the open interval. So am I worried about the fact that the derivative doesn't exist at -5?
No.
No, because it's not in the interval that I care about. Okay? So from there, you're gonna do your stuff, you're gonna solve it, and you should get plus or minus the square root of 5. Both of those are inside the interval, both count. Would this be a good one for me to pick up?
Yes.
All right, let's go. I was like, yes! Mama needs some good grades. All right. Good enough. All right, so if you can put the homework in the middle of the table, and I need you, as completely as possible, to write out the mean value theorem on your own without looking at your notes. If you can do that, call me on over and you can go get your donut.
Where?
So in your notes, picking up wherever we left off yesterday, whatever page that is, page 13 at the top, in your own words as completely as possible, state the mean value theorem. When you've got it, call me on over so I can give you a donut. If you are wrong, I'm gonna eat your donut. What? You think it's for free?
13.
What kind of is?
So if you guys all get them wrong, make them sick.
Hey.
Hey, and you know what? All I would do is throw up in front of you and keep teaching.
Hey, you see,
You can't do that. That's policy. You have to go home.
No, I don't. It's if you are running a fever and if you're foolish enough to tell people about it.
We got it on film. We don't tell anybody.
I'll take it all down. It's called whatever it takes.
Read the sign.
I'm just looking for a statement
Does
of the
someone
mean
wanna-
value
So
theorem.
we're saying this. That's what you what it means. Not how to find it.
No. I'm telling you, I'm asking what is the mean value theorem?
Is everyone saying?
Oh.
No, sit down. Sit down.
Thanks, sir.
You had your chances.
that was what I'm saying.
I like it.
You know when you got it.
It's a lot of stuff. Man.
Friends at North Central and East End, sorry I can't get a donut over to you. No, that's not it. Sorry. But friends at North Central, maybe Mr. Simler has donuts in his new car. I think you should go and look for them. All right, proves that they're no. Okay. I want the statement of the mean value theorem. What do you need to know about the function? What are you promised by the mean value theorem? There might be, some conditions that we keep talking about.
Just do that. You said no.
I wasn't listening to you. Okay. Oh, no, mijo, no. What does it say? Oh, no. Sorry. I'm going to be on a sugar rush by the end of this period. All right. Oh, no. No.
Oh.
No. So close. Check your notes. See if you can figure out what's wrong. Differential. Oh no!
New things that you could not.
Oh wait. Sorry.
Just his face.
God bless. Go get your donut. Much better. Go get your donut. Be more specific. I'm not in love here. No.
Why are you raising your hand?
There are 11 donuts left because he ate one.
Do you know the mean value theorem?
Of course he does. He went to rice for goodness sake. I can't get that you.
That would mean anything.
It's not specific enough. Hey. Hold on.
I'm gonna do it.
Do your donut.
Writing like you told us to be more specific.
Yes. No, still no.
Are we really using tissues?
Yes. In case you got a problem.
All right. Everyone's gonna get a baby.
Yeah.
Right, Andy?
I want you to ask him to find out.
There you go. You already had donut. All right, so here's what I'm looking for. Everyone's gonna breathe. Everyone's gonna get a donut. Look, if I don't give everybody a donut, I'm not being fair. I'm not gonna get good survey results. You're not gonna go to college. You're just gonna stay here and torment me. Function is continuous on AB and differential on AB. Love it. Go get yourself a donut. Woo! Okay. The mean value theorem. The two conditions. Everyone's gonna get a donut. It's okay.
I got it. I did the same thing, by the way. You're wrong.
No. Okay, so here's the problem.
I know what's wrong. Please don't.
The conditions are about the original function. The function is continuous on the closed interval. And the function is differentiable on the open interval. One of the common mistakes I saw was a lot of folks saying f prime is differentiable. F prime is a whole new function to talk about. It's the original function f that has to be continuous and differentiable. I think the confusion is like, how do we check differentiability? You find a derivative, but you're looking at the derivative to see if the derivative exists. You're not looking to see is the derivative differentiable. That would mean like the derivative of the derivative exists. So this is the problem. That value of c has to be inside the interval, and the slope of the tangent line has to be equal to the slope of the secant line. Everybody's okay? All right, good. So here's the goal. The rest of the day, we're just going to get some practice with mean value theorem. Nothing new coming your way. We're going to do a little partner practice, and oh no, there's an odd number of people in the room. But an even number when you include the camera. Yes. Yes. So you have 2 minutes working with your one partner on problem number 1. You only get one partner. If you don't have a partner, the camera is your partner. 2 minutes, question number 1. Make it happen.
He was part of the system. He ate a donut.
Because I know the mean value here.
He went to Rice. He can do whatever he wants. 2 minutes. Make it happen.
Wait, problem 1?
Problem number 1. So David is with the camera. Giselle, if you can just scoot over. And David, you're going to take the seats. Stop breathing heavy on my camera. You're going to fog on my camera. All right. So you're going to read through the problem, have a conversation with the friends at North Central. Okay, focus.
Alright, the figure to the left shows the graph of differentiable function f for 1 greater than, less than or equal to x, less than or equal to 5. Which of the following could be the x coordinate of a point at which the tangent line to the graph of f is parallel to the secant line through the point of f1, f of 1, and 5 f of 5. So first, check continuity.
You can't even see half the thing.
Bro?
Or like, you can see.
Right, they're not gonna be able to see your hand out, but they can see your face.
Arm.
Okay.
Alright, so first check continuity on the interval. Wait, 1 to 5. Draw that line. Draw your line. And then check continuity. Then you have to check this differential. So yeah, and
So it's gonna be a negative. So we can call. Oh, yeah.
so if it is, then
All right, quick show of hands. How many guys went with A?
You're right.
I ain't
Nobody.
finished.
B. C. 2 people, 4 people, 8 people. D. E. How many guys have no idea, to be honest? Okay, thank you for the thank you for the honesty. All right, figure to the left shows the graph of a differentiable function. Okay, great, differentiable, that seems important. Which of the following could be the x-coordinate, blah, 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 blah. Is this a mean value theorem question?
Yeah.
But wait, it only says differentiable.
But in order to be differentiable,
But in order to be, that's the thing, I just heard it. In order to be differentiable, you first have to be continuous. So if all they say is differentiable, you get continuity for free. It doesn't work in the other direction. You can say continuity, but it doesn't mean differentiable. All right, which of the following could be the x-coordinate of a point at which the line tangent to the graph of f is parallel to the secant line? Secant line, all right. So here's 1 f of 1, here's 5 f of 5. Secant line just says connect them. Where's my tangent line going to be parallel to that line? I can think of my other marker just kind of like representing the tangent line. I can slide it up, I can slide it down. Where are they going to be parallel? I see like this guy over here for sure. And anywhere else?
no. It's there.
Nowhere else?
Yes, in the
What about like
right there.
here?
Yeah. No, not there. Like towards the.
Right, so that's the thing, like, you do have another tangent line that is parallel to the secant line, but it's not at one of the given points. There are 2 places, only one of them we have labeled, and that is, what letter is that? I guess? U. Alright, everybody good?
That's your C.
Everybody has to switch partners. You cannot be working with the partner that you're currently sitting with. And sitting with means this group of 4.
David. Now everybody over me, huh? Nah, I don't watch y'all now.
Okay, let's get started. Next question.
Alright, Steven, I got you this.
Alright, Giselle is living in fear right now. Lewis, okay. Can you scoot over so Lewis can sit here? Lewis, your turn with the Trailblazers and the Explorers.
What is the slope of the tangent line?
Number 2.
David.
So you find the slope of the. Eight minus 5 over 8. Just kidding.
Lewis, did you get your donut?
Yeah.
David, did you get your donut?
Yeah.
Minus 5.
Well, you guys are number 2.
Huh? Wait.
So you don't want to do it?
That's
Oh, you do.
yeah.
Aaron, Giselle, did you guys get your donut? Carmen and Celeste, you should get donuts.
Yes. No.
Do you want some?
But the reason is,
Motion for partner?
Friends over here, do we get a donut? If anyone tells any of the AQR students, you will never get donuts again.
Not true, they don't deserve it. I'm serious.
You will never get another donut in your life.
hey guys, you can take on a side.
From me.
Oh.
Alright, it's looking like, it looks like most of you guys are done.
They can't understand your handwriting.
Yeah, they can.
Alright. A portion of the graph of differentiable function f is shown to the left. Alright, if the value c equals 3 satisfies the conclusion. When we say this satisfies the conclusion of the mean value theorem, it just means that it's the c value that we need, where f prime of c equals f of b minus f of a over b minus a. That's what we mean by satisfies the conclusion. It's the c you were looking for all your life. Alright, on the interval -2 to 8, secant line here, and we find the slope is at -3? So -3 minus 5. -3 minus 5 over, is that 8? 8 minus -2. 8 minus -2, that should be -8 over 10, which I think is -4/5. And that should be C. How many guys have C? We get mean value theorem under control?
Yes.
Good, alright. Time to switch. Same rules from before, whoever going to be the most central kid, that's your C.
I got Steven though.
No, I asked Steven.
Alright, you can ask me first. I'm not gonna lie.
Alright, 2 minutes on question number 4.
No, I got it.
Question number 4, because you don't put fast enough, Pablo.
I asked Steven.
Pablo, we've got trailblazers and explorers in need of your special attention.
It's because I'm special, doesn't mean I'm ready like to switch. Continuous function is divided into -4. The graph of the function shown at the left consists of a line and 2 curves. There is the value a, 1, -4, blah, blah, blah. Do we have to talk?
Oh, okay.
We can work it out.
If you could talk to the camera, that would be great. They need you.
I feel like you're the better teacher.
I am the better teacher, but they need you.
Yeah, you have
They need you,
to
mister.
graph it. You would have done.
So, 25.
Then 5 and 5.
Two, there's no need to be 1.
But you also know that f is -5.
Wait, also,
We go down again.
actually,
Oh, no, right.
Yeah, I know.
it was greater than 4.
So then the answer is the graph of f of x.
Well, any of these numbers work with this first one. But
Yes,
this
it goes
one,
up and down.
it's this one
So we have a
right here.
maximum.
Because if f prime equals, f prime c equals 3.
For some C.
Wait, that's,
We're on number 4?
Yep.
Oh.
Yeah.
Oh, what?
It's like it's between 2 and 5.
Oh, well then.
Okay, I mean, yeah,
Oh,
that's
yeah.
right, but I don't know.
Okay, how many of y'all are doing number 3?
-5 is 5.
Okay, we're on number 3.
Are we on number 3?
And you two are just going to stay together. You guys keep doing your thing.
you're not talking to
It's a
me.
beautiful relationship.
Oh.
So we,
So we did it?
If you're on number 3, keep going on number 3.
We did it?
Okay, we're going to blame this on the sugar running through your system. Alright, first of all, I want to let you guys know I put question number 3 on the unit test 2 years ago. Only 14% of students got this one right. Bloodbath. Bloodbath. if you're blindly guessing what percentage of students should be getting this right?
100.
Blindly guessing? Everyone gets it right?
20%.
20.
20%. Thank you for your Googling. Okay? So, 5 answer choices. Blind guessing should get you the right answer 20% of the time. Only 14% of folks actually answer this one correctly. So let's see how well you guys did. How many of you guys went for A? B? C? D? E? Have no idea and would be blindly guessing. Okay, so let's go through this one. All right. A continuous function f is defined in the closed interval -4 to 4. Okay. The graph of the function shown to the left consists of a line and 2 curves. Fine. There is a value a between -4 and 4 for which the mean value theorem applied on that interval guarantees a value of c such that f prime of c is equal to 3. Blah, blah, blah. Are there any answers that we would get rid of right away? The question is about what's the right value for A being the start of your interval. Is there any answer that you have to throw out right away? Which one? Why?
Because
Okay, but can that be the start of your interval?
Yes.
From
Because it's
2 to
continuous.
4,
All the way on up.
can 2 be the start of your interval with the mean value there?
Yes.
On the closed interval.
Right, because your function has to be continuous on the closed. We've got continuous on the closed.
Yes.
And differentiable on the
Open.
open.
Oh.
Don't get rid of A yet. Don't get rid of 2 yet.
You can get rid of -4.
Why?
Because from -4 to 4, there are 2 cusp points where.
Right. Between -4 and 4, I heard you say there's 2 cusp points.
Yeah.
Is everybody okay with the 2 cusp points? So I can't possibly even think about my interval starting there. It's too soon.
So A and E are wrong.
How about 0?
Oh,
You can take one off too.
you can take that one out.
From 0 to 4, can't use the mean value theorem there. You gotta get rid of that. So if I can't use 1 and I can't use 2,
So I stayed. I had 2 there.
It's crazy.
right? I can't use 1, I can't use 2. Oh, that means I can't do this one?
And you can't use E.
And I can't do
E.
that one. Here's what I'm curious about. Can I actually use the mean value theorem on the interval 2
It
to 4?
doesn't matter.
Yes.
Now, obviously, like, if this is the only choice,
Yeah.
then it must be true.
It doesn't matter.
But let's actually make sure that I didn't just blow it here. If I use the MVT on the interval 2 to 4, then I'm saying f of 4 minus f of 2 over 4 minus 2. F of 4 is 12, f of 2 is 6 over 2, what is that, 3? That's your goal, right? There has to be a value in between these 2 points where the slope of the tangent line is 3. Everybody okay? I cannot emphasize for you guys enough, the function has to be continuous, closed interval, differentiable, open interval. All right, time to rotate. We are, unless if you're, you guys can stay together if you need to.
I got you next though.
Okay. This is the last multiple choice question. Everyone is on number 4.
Alright, 4.
4.
Just don't expect me to talk to you. Just don't expect me to talk to you.
You've been shunned. This is what you're behind.
Exactly. Don't expect me to talk to the camera. That's what I meant.
Thank you, LA.
Don't expect me to talk to the camera though.
For some C where
I don't think that
gonna try -2 5 minus plus 5.
No. Oh, it crosses twice. So A
Crosses twice.
Oh, yeah.
It's either C or
well, yeah, because it's from one after. Because
Yeah, this is you're right.
So it's gonna have to be true.
Love it. It looks like just about every single person is plotting those 3 points. Such a good start.
Take off this. Right? It doesn't prove there's a
Take off.
Functionally, I have to.
So yeah.
I guess I did something like that. It doesn't matter.
Oh, yeah.
This F of 10 could be way up here.
Yeah, but I'm talking about just for that point.
For that point. It's like, what if F of 10 goes way up?
Yeah, yeah.
Actually, Had it just said like 4C. Because horizontal tangent means that that the function, like the function, not just right.
Alrighty. We can stop all the good conversations. You know F is differentiable, so that means and continuous at the same time. You've got differentiability, you've got continuity, we get to use the MVT?
Yeah.
Okay, for sure you get to use the MVT, great. On the interval 110, f of 2 equals -5, f of 5 equals 5. What I saw most of you guys do, and I think this is such a good idea, you plotted the points and you said, here's the point, 2, -5. F of 5 equals 5, that means you've got this point at 5, 5. And f of 9 equals -5, you got this point over here. Great. Is statement 1 true? Does F have to have at least 2 zeros?
Yes.
Everybody was convinced with that right away. Polymon, how did you know for sure F had to have 2 zeros?
Since it's differential, it proves that it's continuous.
Because the function's differentiable, that means the function is continuous.
Which means it passes through the x-axis twice.
Right? In order to hit all 3 of these points with a continuous function, you have to you're going to have to hit the x-axis. There's a theorem. Which one is it?
AVT.
AVT, there's no such thing.
IVT.
IVT. IVT. So you get the mean value theorem and you get the intermediate value theorem for sure, saying that my function has to look something like that. At least once, twice, check. So if statement 1 is true, no one's going to pick A.
That's it.
That's it. All right, the graph of F has at least one horizontal tangent line.
Yes.
Yeah.
Why? Why does there have to be a horizontal tangent line? This is Stephen, this is Celeste, this is Polymon. Lewis, why does there have to be a horizontal tangent line?
It goes up and down. Like there has to be like a maximum, so there has to be a horizontal.
Okay, so the function goes up and it comes back down. Now here's the thing. Could
Nope.
the graph look like that? Think about that for a second.
That's a custom.
That's a cusp point. If you have a cusp point, then the function
Not
isn't differentiable. Don't do this. Great. Now here's what I'm afraid of. I think some of you are going to make an argument and say the graph must look like this. That you have to do this. How many of you say this is what the graph has to look like?
No.
Nobody's going to fall for that? Why might someone do that though? Maybe not someone who's in this room. What's the mistake that they're making here? Just Celeste, you got Lewis, Stephen.
They're just connecting 3 points. They're connecting the 3 points given, but they're way more than that.
Right, does this have to be the relative max? No, it could be some other place. It could be coming after, it could be coming before. The reason why you must have a horizontal tangent line is because if I consider the secant line that connects these endpoints here, what's the slope of that secant line?
Oh, 0.
The slope is 0. So if these are the endpoints that I connect with a secant line and that has a slope of 0, guess what? Somewhere this function will have to have a horizontal tangent line. That's why statement number 2 is true.
That's a good way of thinking.
I tried. All right. Statement 3, for some value of c with 2 less than c less than 5, f of c has to be equal to 3.
No.
It's C is supposed to equal 3, not F of C.
Oh, notation, right?
Right?
F prime of C?
He said that so confidently, and then he said,
Is that probably
Right?
with the notation?
Does there have to be a place where f of c is equal to 3?
Or is it?
Wait, some C or like?
No.
Does there have to be some value of C between 2 and 5 where f of C is equal to 3?
Yes.
How many guys would say yes, there has to be a place?
That would be.
How many guys would say no, there doesn't have to be a place? Some of y'all have no idea. Be honest.
Yes.
Okay. Look at the points that you plotted. Does there have to be a place between 2 and 5? Between 2 and 5
It's yes because
where f of C is equal to 3? To go from here to here with a continuous function? What theorem applies?
The mean value theorem has
Not the mean value theorem.
IBT.
The IBT. The IBT promises this. So that's why it's going to be statements 1, 2, and 3. Everybody okay? Sneaky question, I know. All right, Ile, you want to scoot on back. Everybody can go on back to their places. Stephen, make sure I'm still looking good on that camera. Oh, no doubt. No doubt. No doubt. All right. We've got 12 minutes left. I want to get these 2 free response questions done. Aaron, are you okay? You look like you got lost on the way to your seat. It's back here. You got way lost. All right. Multiple choice, you guys did a good job. Most of you got at least 3 right, some even 4 right. There is one multiple choice question that we didn't do. I need you to finish that for homework. Oh my God. All right, there are 3 free response questions. My goal is to get through at least 2 of them right now, leaving you just 1 to do this weekend. This is like the lightest homework assignment. All right. Free response question, here it comes. The rate at which water flows out of a pipe in gallons per hour is given by a differentiable function r of time t. The table below shows the rate is measured every 3 hours for a 24-hour period. Is there some value of t where r prime of t equals 0? We've done questions that look and sound and feel like this before with the other theorem. The IBT. Does there have to be a place where the derivative is equal to 0? And if so, you have to tell me what interval. And you have to tell me why you get to do this. So, before we get too far into this, is there anywhere in this problem where they use the phrase mean value theorem? No, there is nowhere in this problem where they say, hey David, mean value theorem. You need to know that you are using the mean value theorem, and there is a clue in this problem that says I should be thinking about the mean value theorem. There's a clue. Aaron, what's the clue?
It's given by a differentiable function.
That's actually not the clue. That differentiable is important. I wouldn't necessarily say that's the clue.
It's the
It's in the question. What are they asking for? They're asking for some place, some value of t where something special happens. You guys are focused on all the wrong things. The whole like, there's some place and it exists, that's also language in the IVT. Right, does there have to be a place where r of t has some value? The fact that they're asking about the derivative taking on some particular value, that would be the clue that it's a MVT, because the MVT concerns itself with derivatives. So, everybody okay with using the MVT? I need to be convinced. I need to be convinced that we can use the MVT. Celeste.
You know that because it says that R of t is differentiable, it must be, R of t must also be continuous.
So I would say something like R of t is differentiable and therefore continuous on, what's the interval here?
0
On 0 to 24. Tell me what we know. Because I've got differentiability and continuity on the interval 0 to 24, what do we get to do? We get to use the MVT. The MVT applies. Okay, so if the MVT applies, like getting there, honestly, is probably going to give you the first point. Where Does it have to be true that r prime of t is equal to 0? Has anyone found an interval where this has to be true? Stephen did, Celeste did. Where would the derivative have to be equal to 0, Myra? Where do you see it?
From 0 to 24.
From 0 to 24, convince me that the derivative has to be equal to 0 somewhere in between here.
Although they both have the same y.
They both have the same y value, so what does that tell you about the slope?
It's 0.
The slope has to be equal to 0 between 0 and 24? So here's the write-up. Don't use the wrong function name here. We've been using f and a and b. It's not f.
So it's R.
It's r. R of 24 minus r of 0 over 24 minus 0. Well, that's 9.6 minus 9.6 over 24, which is 0. Be careful though, because this is not slope of tangent, this is slope of secant. The slope of the secant line is equal to 0. What does the MVT tell me? The derivative must be equal to 0 where? Somewhere. So that's all I care about. I don't know where. I can't say, oh, here at 12, here. I don't know. What I can say is then r prime of t equals 0 at least once, and then give me the interval. On the interval 0 less than t less than 24. I'm being careful to not include endpoints here. The MVT doesn't promise you anything about endpoints. It promises you about the interior. Everybody okay? You have to convince me that it's okay to use the MVT. You're going to have to show me that you found slope of secant line. And then your conclusion is going to be, oh, my derivative has this value at least once in the interval 0 to 24. Everybody good? Yeah. See what you can do the next one. Read this one carefully. Test plane flies in a straight line with positive velocity in miles per minute at time t minutes, where v is differentiable. God, I love that word. Selected values for v of t are shown in that table below. Based on the values in the table, what's the smallest number of instances at which the velocity could be equal to 4? You guys should make your fingers how many times? What's the smallest number of times that the velocity could be equal to 4? 2, 2, 2, 2, 2. Aaron, where's one of the places?
T equals 25 minutes. Or from 20, from between T equals 20 and T equals 25.
Yeah, you gotta be careful. You wanna give me an interval. So in between 20 and 25, is it okay that has to happen there at least once? And Ailey, where's the other place?
Between 30 and 35.
Between 30 and 35. Now be careful. I love those two answers. What theorem are we using right now? IVT, not MVT. All you need right now is continuity. So I hope your write-up looks something like this. Their question, what's the smallest number of times the velocity of the plane could be equal to 0? Answer their question first. 2 times. And I'd say something like, since v is differentiable, this implies continuous. IVT applies. I heard, Aaron, you said on the interval 20 to 25?
Yes.
Okay, and that is because the velocity at time 20 is 4.5. The velocity at 25 is equal to 2.4. I'm showing that I've checked the values of my endpoints. And why these endpoints? I know that 2.4 is less than 4, and that's less than 4.5. Therefore, v of t equals 4 at least once on the interval 20 to 25, and then pretty much the exact same right up on the interval 30 to 35. Yeah. Everybody okay? All right, we've only got 3 minutes left. I'm really interested to see what you guys can do with part B. So we go to 9:33.
Part B.
Okay.
Alright, we're out of here.
No, wait, we need to okay.
The people are going out of the class.
Okay.
You just take 8 minutes off of the normal dismissal time.
8 minutes, yeah. All right. So did you say 9:35 to 10:22? And then it's 10:26 to 11:04. My bad. All right. So homework this weekend before Giselle runs out of the room here. Homework this weekend. There's one multiple choice question that we didn't do. Finish up this one free response question and the next one. This is like 15 minutes of homework.
So 2 free response homework.